Hello, we are back and we are talking about, and today we'll discuss about a topic called as recursion. So ideally, what is recursion? Recursion, the word itself means repeating. Yes, the process of a function, if a function calls itself repeatedly, if a function calls itself repeatedly, then this is called as recursion. So recursion is a process of function calling itself repeatedly. Say example, if there is a function f1 and in the definition of f1, if there is a function f1, in the definition of f1, if f1 tends to call f1 again, so a same function calling itself repeatedly is known as recursion. So recursion is a process of, recursion is a special case of nested functions. Recursion belongs to a special case of nested functions. Nested means one inside another. If inside a function, you call another function, it's called as nested functions. And in recursion, instead of calling some other function, we tend to call the same function called f1. So what happens inside recursion and how is it different from something called as iteration is what we're going to study today with an example program. So therefore, what happens inside recursion? So if there is a function f1, inside the function f1, you again make a call to function f1, and this process is repeated for some finite number of times, and this is called as direct recursion, where a function calls itself. On the other hand, there is something else called as indirect recursion, where there is a function f1 in which you call another function called as f2, where f2 in turn calls after a while f1. This process of indirectly calling a function again is known as, obviously, indirect recursion. So there are two types of recursion, direct and indirect. Direct is a function calling itself, and indirect is a function where the function calls another function and the second function tends to call the same function again. So this is indirect recursion. So we'll now move to study something called as recursion versus iteration. So iteration is a process where we use a loop, any loop, to get a job done. On the other hand, recursion, instead of using a loop for repetition, uses a function called itself. So for example, if I have to find out the factorial of a given number, so we write for I is equal to 1, I less than or equal to 5, I plus plus. We write f is equal to f into I. And this is how you calculate your factorial, where you initially set f. For this equivalent iterative code, let us try to understand how do we write a recursive logic. Recursive logic employs a function that is used to repeat itself to calculate the factorial of a particular number. So what does recursion ideally do? Recursion is purely a formula based logic writing, where you almost write your logic very close to a formula. So let's try to understand how do we code factorial using recursion. How do we code factorial using recursion? Say for example, n is a number for which you are trying to find factorial. So therefore we are trying to find n factorial. Say if n is 4, how do you find out 4 factorial? 4 into 3 into 2 into 1. Or in other words, we write it as 1 into 2 into 3 into 4. Now, my dear students, can I write 4 factorial as 4 into 3 factorial? Yes or no? Obviously, yes. Can I now write 3 factorial as 3 into 2 factorial? Yes. Can I write now 2 factorial as 2 into 1 factorial? Yes. Can I now write 1 factorial as 1 into 0 factorial? Yes. Now tell me what is 0 factorial. We all know that 0 factorial is equal to 1. So take this value back. 0 factorial is 1. So in the place of 0 factorial, substitute your value 1. What is 1 into 1? 1. So in the place of 1 factorial, substitute your value 1. What is 2 into 1? 2. So in the place of 2 factorial, substitute your value 2. What is 2 into 3? 6. So in the place of 3 factorial, substitute your value 6. What is 6 into 4? 24. Did you get the answer? Yes. So how do you code it? What is the other way of coding it? So recursion obviously involves something of very factorial. So finally I can conclude by writing n factorial is nothing but n into n minus 1 factorial. So therefore C language does not support any symbol like factorial to straight away calculate the factorial of a given number. So in other words, as a formula, if I can put it, then I write fact of n is equal to, if this symbol, I take this symbol as fact, then I write fact of n is equal to n into fact of, what do you write? N minus 1. So therefore, this is the formula that holds and that we use to calculate the factorial of a given number using recursion. So according to this, how does 4 factorial translate into? Let us see how does 4 factorial translate into. 4 factorial is nothing but fact of 4. Fact of 4 is equal to 4 into fact of 3. So fact of 3 is equal to 3 into fact of 2. So fact of 2 is equal to 2 into fact of 1. So fact of 1 is equal to 1 into fact of 0. So therefore, here we found that when we get fact of 0, we have to get this as a stopping condition. So it's time to discuss what is called as stopping condition. So we'll discuss what is called stopping condition in a while. Now let us see what is fact of 0. We all know that fact of 0 is essentially 1. So therefore take the value back. 1 into 1 becomes 1. So here you get the value 1. 2 into 1 is 2. So come back, put the value 2 here. 3 into 2 is 6. So put the value 6 here. 6 into 4 is 24. This is how we get the answer. So therefore, it's time to discuss about what is called stopping condition. So stopping condition, or in other words, we technically call it as a base case in recursion. Stopping condition or base case in recursion is an if clause or an if statement that is used to stop the recursive calls after finite iterations, because anything that is infinite will never give the answer. So for the recursive process to stop after finite iterations, every recursive program or a recursive logic involves an if statement which will have a base case that allows us to get the recursion stop after finite iterations. So therefore, how do you code your recursive call for finding the factorial of a given number? So therefore, if I write a logic that is returning an integer for finding the factorial of a given number n, how do you write its logic? We all know that n factorial is nothing but n into factorial of n minus 1. But how long is this okay? It should stop when your n value is 0. So if your n value is 0, then we all are expected to return a value 1, because 0 factorial is 1. Otherwise, we will return a value n into fact of n minus 1. So this is ideally a logic that we write to find out the factorial of a given number. So this is what it returns. So if fact of n, if n is 0, it will return 1. Otherwise, it will return n into fact of n minus 1. So this is all about recursion. So but we will now see a program that helps us to understand how do we find out the factorial of a given number using recursion and iteration. So therefore, rfact is a program that is used to find out using recursion, and an rfact is a program which is used to find it out without recursion. So therefore, enter n, factorial of a given number using recursion. You had your recursive call rfact. Using non-recursion, you have your non-recursive call and artifact. So therefore, how do you write your recursive program? As we discussed, if n is 1, you will return 1 because this is the base case. Else you will return n into artifact of n minus 1. So close. How do you write your long int and r factorial? So int I, long int f. So f is equal to f into 1, return f. So this is what you're trying to produce. Alt F, save. Alt C, compile. Alt R, run. Enter n value. So n value is 7. It's 5040. So okay, we run it again. So let's do it for 4. 24. I use long int because it's against the range of my this one. So therefore, to help my program get the answers for bigger numbers, I've used long int as the return type, or you can limit yourselves to integer, depending upon the storage requirements of your computer. So I've used long int for my purpose. You can also do it with integer, not an issue. So this is how you tend to work out. So like that, you can also find out GCD. Okay, we'll discuss about GCD after a while. We'll get back and see what are the limitations of recursion. So what are all the limitations of recursion and recursion versus iteration? So yes, this is how you produce a recursive call. Recursion versus iteration. So recursion is a situation where a function calls itself, but iteration is a situation where you use your any looping statement. You can use while, do while, or for to get your job done. Recursion is comparatively slower because recursion requires each time a function call, but on the other hand, the execution of iterative statements is pretty faster because they do not require a stack. Recursion employs a stack for supporting its operations, whereas iteration do not employ any stack. So recursion takes more memory because a stack is used, and iteration takes very less memory comparatively because it does not employ any stack. Recursion is smaller because it provides a simple solution to a larger problem, whereas iteration is during iteration the codes are bigger. So let's now talk about the advantages of recursion. Every process will have its own set of pros and cons, or advantages and disadvantages. So talking about the limitations of recursion, the limitations of recursion include recursion is a slower code. It takes much time. It employs more memory. At times when you don't write your base case, there is always a chance that recursion ends up in infinite loops. And it's difficult to debug recursion because you don't know at what call it went, the code went wrong, and it's also difficult to abort recursion. So these are the few demerits of recursion. The demerits are, let's try to understand what are the demerits. The demerits are, it's a slower process, it takes more memory. Number 2, it's a slower process, number 1. Number 2, it takes more memory. Number 3, it requires a lot of proficiency from the programmer to develop the code or write the code. Number 4, it might end up at Stack Overflow, or it might end up in infinite loops if the base case is not properly coded. And number 5, it is very difficult to abort recursion in between. And number 6, it takes a lot of time to debug a recursive call. So these are all the demerits of recursion. But any process that has demerits also will have merits. So what are all the merits of this process called recursion? The merits of recursion includes it provides a simple solution to a complex problem. Recursion many times provide simple solution to many complex problems. So, and also recursion is used in implementing trees, graphs, etc. Tree traversals, graph traversals only become simple because of recursion. Otherwise, it becomes a very hectic job to code them. And another advantage of recursion is almost similar to a maths formula. Recursion is almost closer to a formula. It's almost pretty similar to a formula that we use to particularly probably solve a particular problem. So recursion is almost closer to a formula. So these are the advantages of recursion. Try it on your own. Try to write GCD on your own. We'll meet in the next class.